All right, so we've talked a lot about lines. We've talked about line segments. We've talked about how to add these line segments together, the betweenness of segments, of points, excuse me. But today we're going to talk about some things that are a little more specific about line segments. The first thing we're going to talk about are midpoints of a line segment. So midpoint is exactly what it sounds like. Midpoint is the middle of the segment. Okay, so we're going to, oh goodness, I had a glitch on my computer. We're going to look at this on a number line as well as on the coordinate plane, just like we did with the distance, finding the distance or the length, middle of the segment. Okay, so let's start with the number line, okay, because it's probably about the easiest to look at. So let's say, here's my number line. We'll use point P and point M, okay? And let's say that I want to know, and point P, we'll call this X1, and point M, we'll say that's it. And in fact, let me label this a little bit differently so it won't confuse you at all. Let me put the name of the point above. There we go. That'll look a little bit better for you. And so this would be X1 and this would be X2. And of course, if this is a number line, maybe this is 1 and this is 5, or this is 0 and this is 2, whatever place they're at the number line, but we're just going to let it be called X1 and X2. So in order to find exactly in the middle of this segment, what I would need to do is I would need to take those two numbers, add them together, and then you probably guessed it, divide by 2, okay? And what that's going to do, we'll call it M for we can't call it M because we've already used M, haven't we? We'll call it K, okay? So this is how I would find the value of that point K, is I would add them together. Essentially what I'm doing is I'm averaging the 2 points, okay? So let me show you an example. Let's say that I had, let's say, and this is actually an example in your book, let's say that I had a picture frame that I am hanging on the wall, right? And we'll call this point A and this point B, and I need to find exactly in the middle of these 2 points, because you know how it has a little wall hanger on it that you have to find, and it's so aggravating, but let's say we have to find exactly in the middle of these 2 points, all right? And let's say that point A happens 15 inches from the left side of the wall. So we'll say this happens at 15. And point B happens at 37.5 inches from the wall. So essentially what I have is I have this nice little, my goodness, it's glitching a lot, isn't it? Let's say I have this nice little line segment AB. We'll call this 15, we'll call this 37.5. So if I need to find the midpoint here, what I need to do is I need to average these together, right? Because that's how I find midpoint. So go ahead and do it, and you can pause it and check your work with me, and we'll come back together. All right, so if I average them together, I have 15 and 37.5. And I'm going to divide that by 2. And calculators are A-OK if you need them. Of course, we shouldn't rely on them if we don't always need them. But I would have 52.5 divided by 2. So the middle would be right at 26.25 inches. That would be exactly the middle. 26.25. So a fairly easy concept here, and that would make both of these sides the same. Okay, now let's talk about if we move into a coordinate plane. So a little bit different if we move into a coordinate plane, as things are, because now we have an x and a y and not just an x value, right? But it's still, sorry y'all, the bell's ringing here. It's still the same concept. Let's put our line here. Let's call this P. Let's call this Q. And P has coordinates x1, y1, and Q has coordinates x2, y2. And I want to find the midpoint, okay, exactly in the middle. This is what I'm looking for. What are the coordinates of this midpoint? And so what I want to do is, and it's so very similar to the number line. What I want to do is I want to find exactly in the middle of the x's first. Okay, so what I want to do is add the two x's together, divide by 2, just like I did on the number line, but now I need the y portion of that too, right? Because I need an x and I need a y. So to do that, I'm going to do the same thing, but with y. I'm sorry, y'all, I don't know why this computer just keeps jumping like that. So y1 plus y2, and I'm going to divide by 2. Okay, and that will give me the midpoint. So let's do an example together of a coordinate plane midpoint and see what happens here. Let's say I have segment SM, let's call it ST. And that point S is at -3, and that point T is at 1, 0. I want to find the midpoint of these 2 points. Okay, so what I want to do, again, add the x's together. So -6 plus 1 divided by 2. And for the y portion, I want to add those y's together. So 3 plus 0 divided by 2. And so I find that the midpoint here is -5 over 2 and 3 over 2. And always better to leave this as a simplified fraction than it is to try to throw any decimal or anything in there. Okay? All right, so let's get up a little bit. Let's say that we want to find a point J. And I know that point A is at -1, 2. And I know that point L is 3, -5. And I'm also going to tell you that K, oh goodness, K is the midpoint of segment JL. Okay, I want to know what is J. Okay, well, let's think about this for just a second. I've got K is the midpoint, right? So I'm just going to label this, because that helps me to see it kind of in my head. And this is an endpoint. So essentially, I have one endpoint, I have a midpoint, but this is the one that I'm missing, right? I'm missing the endpoint. So remember, I need to do the endpoint x plus the other endpoint x divided by 2, and then endpoint y, and I probably shouldn't use an e. Let me change that here. Let's do, come on. Well, now, of course, whenever I make a mistake, it's just not even going to work with me, is it? Let's do let me explain this a little bit easier. Let's say I want to find x and y for J, right? What should happen is this x, so that's an endpoint, plus this x, because that's endpoint, divided by 2 should give me the midpoint, right? And then this y, so I don't know what it is, plus the other endpoint's y, divided by 2 should give me the midpoints y, right? And now I can go through and solve each one of these. So here to solve, I'm going to multiply by 2. And so I have x plus 3 equals negative 2. Subtract 3. So x is negative 5. And then over here, same process, I'm going to multiply 2. So y plus negative 5 is 4. And I'm going to add this 5 to the side. And I get 9. Right? So now I know that the coordinates j, the coordinates of j are being negative 5, 9. I wrote it wrong. Negative 5, 9. All right, so one more example. Again, of course, we're not going to leave it. They get a little bit harder as we go, but let's do one more example. Let's say I have this line segment, P, Q, R. And I know my pen must be almost as tired as I am because it is lagging. But let's say I have PQR, and I told you that let's say that I told you that Q is the midpoint of PR, okay? And then I also told you that PQ is 9y minus 2. And I told you that the length of QR was 15 plus 5y. Okay? Now, I asked you to find the measure of PQ, or of PR, I'm sorry. The whole, oh, did I say this backwards? PQ and QR, that's right. All right, and I want to know the measure. Let's say I want to know the whole measure, okay? I want to know what is PR. What's the length PR? Okay, so to do that, I first need to find y, right? I need to find out what y is, and this is a 4, by the way. I don't know why. I'm struggling here. All right. Because Q is a midpoint, that means by definition that these two segments are the same distance, right? So if they're the same distance, let's just set these two things equal. Let's say 9y minus 2 is equal to 14 plus 5y, okay? And let's solve this for y. I'm going to subtract the 5y. So I get 4y minus 2 is equal to 14. Let's continue solving, and I'm out of room here, so I'm going to come. I apologize for the lines and everything. And let's say I'm going to just transfer this equation. 4y minus 2 equals 14. Let's add the two both sides. So I have 4y equals 16, and then of course divide by 4. So y is 4. Now that is not what the answer to the question that was asked of me. The question that was asked of me is what's the length of the whole segment, right? So if this segment is, this PQ is 9y minus 2, and QR is 14 plus 5y, what I want to do is substitute this y value in. So PQ going to be 9 times 4 minus 2. So it's going to be 36 minus 2, which is 34, right? And then QR is going to be, same process here, QR is going to be 14 plus 5 times, remember that y is 4. So I have 14 plus, I'm running out of room, I'm sorry guys, plus 20, which is 34. right? And they should be the same because Q is the midpoint. So that's perfect that that came out that way. So the length of the hole would be 68. Very last thing for this section, and I will be done, I promise, is fractional distance. I know that we all love fractions, right? Because fractions are our friends. And so what I want to do is I want to take a line segment, and let's say this line segment was in M. And let's say that the coordinates of N are 3, -3, -3. And the coordinates of M are 3. So my question to you is, can you find the coordinates, can you find point R on this segment that is not half but a quarter the distance from N M? Okay, so a quarter of the distance. So the thing that I need to know is, well, what is the distance in order to know what a quarter of the distance is, right? So let's first look at the x coordinate. For the x coordinates, remember to find distance, I'm going to use that little distance formula. And right now, I don't want to know the length here. I want to know the distance between the x's. So I'm going to use the absolute value, right? And I am going to subtract these. So -3 minus 2. And I want you to understand why we're not using that distance formula coordinate, even though these are coordinates, because the distance formula would simply tell me on here the length. What I want to know are the actual coordinates, okay, and not the length itself. So halfway between, let's see, so -5, the absolute value of -5, right, is just 5. Okay, now what I want to do is I want to multiply this distance, okay, because that's what this is this is a distance of 5. That means from -3 to 2 is 5 units. Remember, I wanted a quarter of the distance. So what I want to do is I want to say, okay, if the distance is 5 and I want a quarter of the distance, I want to multiply by that. And I get 5 over 4, which is 1 1/4, right? 1.25. So what that means is 1.25 units from here, I get a quarter of the way over. Okay? So if I take that coordinate, which that coordinate was -3, right? -3, and to it, I'm going to add 1.25 because that is a quarter of the distance. Then what I get is -1.75. That is the x coordinate of the point that is a quarter of the distance. Okay, now look at the y. So if you didn't get it on the x coordinate, let me show you with the y and it'll make a little more sense. The process is the same. For y, again, how far is it from the y coordinate to this y coordinate? So -3 to 3 is 6 units, right? This is -6, but then it becomes +6, all right? So from -3 to 3 is 6. I want a quarter of the distance, okay? So a quarter of 6, I multiply, and I get 6 over 4, which happens to be 3 halves, which is 1.5, right? So 1.5 units from -3. Well, -3 plus 1.5 would be 1.5. So what I have here is I have, the coordinates of the point that is exactly a quarter of the way from N to M, and that is the point R, which is -1.75, 1.5. Okay, so I could put it on plan. This is, on my segment, this is R, which is -1.75, 1.5. I think that is enough for you guys for today. Give you some practice with this and let you loose.